Hi students, today we are going to study Stoke's law in viscosity. Now in this picture, there is a beaker containing a highly viscous liquid like glycerin. Okay, glycerin is having high viscosity comparing to water, and inside which I just drop a small metallic sphere. You can see here, this is a sphere which is dropped inside the liquid. So as I drop the sphere, it will descend in the downward direction. So as the sphere is descending downward, the weight of the sphere W is acting in the downward direction, and equal volume of the liquid is displaced, due to which an upthrust U is acting on it in the upward direction, and opposite to the direction of descending, a frictional force, namely viscous force, is acting in the upward direction. So when the sphere is descending downward, it moves through the different layers, okay. So it drags the different layers of the liquid and it is moving in the downward direction. Okay, so due to which there is a relative motion between the different layers of the liquid, and the frictional force, namely the viscous force, is acting in the upward direction, that is in a direction opposite to the movement of the sphere. Now this scientist Stoke performed this experiment and he derives an expression for the viscous force acting on the sphere in terms of the coefficient of viscosity of the liquid, and in terms of the radius of the sphere, and in terms of the velocity with which the sphere is descending in the downward direction. In the previous video, we have already studied what is terminal velocity, is it not? When the sphere is dropped freely, its initial velocity is equal to 0. Then as it is descending downwards, the velocity is continuously increasing till it reaches a maximum constant velocity called the terminal velocity. So in between the starting point and the terminal velocity, any value of the velocity we are going to consider today. So now you can see in this what are the terms we are going to use in this derivation. First, eta. Eta is what? The coefficient of viscosity of the liquid taken in the container. Then R is the radius of the metallic sphere which is dropped inside. And V is the velocity of the sphere at any instant of time. And F is the viscous force acting upwards. U is the upthrust acting on the sphere, that is also upward. And W is the weight of the sphere which is acting in the downward direction. Okay. Now we want to derive Stoke's law and get an expression for the viscous force in terms of eta, R and V. So for this we are going to use the dimensional analysis. In the first chapter we have studied dimensional analysis can be used to derive the relationship among the various physical quantities. So now let us take from the method of dimensions, okay, from dimensional analysis. I can take the physical quantity, namely the viscous force, depends on the three factors eta, R and V. Therefore, I can write F is proportional to eta, F is proportional to R, and F is also proportional to V. Now we do not know how it is proportional to, whether it is square of the radius or square root of the velocity. We do not know the powers to which the right hand side terms are raised. Is it not? So I will take the power of coefficient of viscosity is x, and that of radius is y, and that of the velocity is z. So F is proportional to eta power x, R power y, and V power z. Or F is equal to a constant of proportionality k into eta power x, R power y into v power z. So this is the main equation number 1. Here k is a dimensionless constant. K is a dimensionless constant. So it does not dimension, but it has a numerical value that is equal to 6 pi. The value of k has been determined by experimental method, not by dimensional method, and the value is found to be how much? 6 pi. At the end we will substitute k equal to 6 pi. Okay. Now the dimensions of the various terms. So the dimensions of force. So the dimension of force is mass into acceleration, m, l, t power minus 2. Then coefficient of viscosity is m, l power minus 1, t power minus 1. Then the radius is merely length only, so it is l. And velocity, so the dimension of velocity is L t power minus 1. So these are the dimensions of the various terms on both sides of the equation 1. Now I will substitute the dimensions on the left side and right side of equation 1 except k. So on the left hand side, instead of force, the dimension is m, l, t power minus 2. And this is equal to right hand side, first term is eta. So its dimension is m, l power minus 1, t power minus 1 into r power y. Before that here eta is raised to the power x. So I can write here the power x. The second term is r power y. Dimension of r is l and the power is y. And the third term is v power z. So this is l t power minus 1 whole power z. So now left hand side m power 1, l power 1, t power minus 2 is there. The right side it is m power 1, l power minus 1, t power minus 1. Now here m is raised to the power 1. But whole power x. So m is raised to the power x. And here there are no mass term. Therefore, see, I will write here left hand side m power 1, l power 1, t power minus 2 is now equal to m raised to the power only x. Then l is raised to the power minus 1. But whole power x means l power minus x. And here l power y. And here l power z. So totally l is raised to the power. L is raised to the power. Here minus 1 power x is minus x. L power y. So here plus y. And l power z is plus z. So L is having power minus x plus y plus z. Now left hand side t is to the power minus 2. Right hand side here there is t term. So minus 1 whole power x is what? Minus x. And here there is no time factor. And here t power minus 1 whole power z is minus z. So here t power minus x. Here t power minus z. So this is into t power minus x minus z. Okay, now I am going to equating the powers of m, l and t on both sides. So I am going to equate the powers. So equating the powers, equating the powers of m, l and t. Left side is m power 1, right side is m power x. So x is equal to 1. The value of x is directly derived. So this can be taken as equation 2. The value of x is equal to what? 1. Similarly, next one minus here I will first take the value of t first. So here there are only two variables, isn't that? So left side is t power minus 2 and right side is the t power minus x minus z. So I will write minus x minus z is equal to minus 2. Minus of x plus z is equal to minus 2. So x plus z is equal to 2. Isn't that? This implies x plus z is equal to 2 or z is equal to 2 minus x. 2 minus x. But x value is 1 already we have determined. So this is equal to what? 2 minus 1. Okay, equal to 1. Therefore, z is equal to 1. And this is equation 3. Now we can go for the middle term L. So left side is L power 1. Right side is L power minus x plus y plus z. So minus x. So minus x plus y plus z. And this is equal to L power 1. So L power 1. Now the value of x is equal to 1. So instead of minus x, shall we write minus 1? So this will become what? Minus 1 plus y plus z. Z value is what? Plus 1. So 1. And this is equal to 1. So this minus 1 and plus 1 get cancelled. Therefore what is y is also equal to 1 itself. And this is equation 4. Okay. Already the value of k is equal to 6 pi. Now we have found the three unknowns x, y and z all are equal to 1 only. Isn't that? So I am going to substitute the powers x, y, z is equal to 1 and k is equal to 6 pi in equation 1. So substituting the values of x, y, z and k in which equation? Equation number 1. So in equation 1, so f is equal to, the value of k is 6 pi, eta power 1, okay, r power 1 and v power 1. Therefore f is equal to 6 pi eta r v. So this is the final equation number 5. This only is called Stokes' law. This is very important. This question will be asked in the board examination for 3 marks. So you should be thorough with this derivation. Sometimes it may be asked in 5 marks also. Okay, because it involves so many steps of dimensional analysis. So what is Stokes' law? What for it is required? Stokes' law is used to find the viscous force acting on a solid sphere which is freely falling inside a highly viscous liquid like glycerin, castor oil or honey. So we can measure the viscous force acting on the solid sphere which is dropped inside a highly viscous liquid. So what is Stokes' law mathematical form? F is equal to 6 pi into eta into r into v. I hope you must have understood well. Fine.